Hello dear students, we were discussing about Module 5, that is Geosynthetics and reinforced soil structures. In this we will discuss about types of geosynthetics in detail. So these are the types of geosynthetics which we already discussed. We will discuss one by one in detail. Geotextiles, these are the engineered sheet like products made up of natural or synthetic materials. This may be of oven and non-oven types. These are mainly used for separation function, drainage as a drainage material, as a filtration. Also we are using this as a erosion control and also as a reinforcement material. So there are two types mainly. We classify geotextiles into two categories, like woven fabric, where you can observe the weaving pattern like our cloth materials. Non-woven, which is the fibers are randomly oriented. These are manufactured by knitting process or maybe bonding process. So if you observe, there are some pictures I have shown here. There is a thin geotextile used as a separator as well as filtration function. There may be thick geotextiles which are used as a cushion material as well as a drainage medium. So natural geotextiles also we are using, like woven and non-woven geotextiles. This is one of the application of geotextile material is being applied below the railway track. This is the railway track which has been constructed on the a soft soil. So when the rainwater mixed with the below soil, subgrade soil, so while the wheel movement or the rail moving, there is a dynamic load is applied, so the water comes along with the soil particles. So there is a continuous loss of the fine grain particles there. So to avoid that, the geotextile has been applied, so that to avoid the loss of fine particles, so that it will retain the strength of the subgrade. So as well, the before application of this geotextile, what happens, there is a reduction in the rail speed, but after applying this geotextile material, the train speed has been bring back to the original design speed for about 80 to 100 km per hour. Next we have geogrids. These are the sheet like products with open apertures. These are having a large open apertures which provides excellent interlocking with the soil when used along with the soil. This provides excellent interlocking. High strength products used for reinforcement. So there are different varieties of geogrids we are having, like extruded geogrids have low strength, like Nelton India products, maybe stretched, which is stretched grids which are having very high strength. So more recently the types are made by knitting process as well as welding process, etc. So there are mainly two types we have. So uniaxially stretched geogrids and biaxially stretched geogrids. So uniaxially means they are stretched in the manufacturing process in one direction, so they take the load or distribute the load in one direction. So uniaxial products we are using as a reinforcement layer in retaining wall and embankment, where the load distribution in one direction. So biaxial, where the load distribution takes place in more than one direction, like road bases below the railway track and ground as a ground reinforcement, we are using this type of geogrids. So stretched uniaxial geogrids have been shown above, and these are knitted polyester geogrids. This is the application of the geogrid in the manufacturing or construction of the landfill at Visakhapatnam to store the geroside waste at Hindustan Zink Limited, Visakhapatnam, as a reinforcement material. So geogrid reinforcement in pavement also we are using geogrids as a reinforcement materials. Next we have GEONETS. These are also planar products which consists of rifts in two directions of diamond shape. Here the difference is GeoGrid and GEONET, the difference is these are having ribs in two direction and in different planes, so that they make the shape of the aperture of diamond shape. So thickness of the GeoNet is larger than that of the GeoGrids there. Then GeoNets are also referred as geospacers. So this is a typical GeoNet. You can observe the ribs at two horizontal planes which are in different planes. They are different planes, so there is a diamond shape. You can observe the aperture is of diamond shape. The thickness is also more than the GeoGrids. So application, typical application, we have erosion control as well as drainage layer because of the ribs which acts as a small check dams, so to slow down the surface runoff which decreases the erosion potential. So drainage layer, water flows along the GeoNet because of the larger thickness, so these GeoNets can effectively applied for erosion control as well as drainage layer. This is a typical example of boulder net laid on Konkan railway line in Western Ghat, which functions as a guide for loose boulder and also which support or promotes the vegetation growth there. So before laying of this boulder net, so there is a fall of the boulders or rocks in the rainy season to the railway track. So to avoid that, so boulder net has been laid, so which acts as a guide for the loose boulders there. So in first figure there is a laying of boulder nets has been shown. In the second, after 2 seasons you can see there is a growth of vegetation there. So at the top we have to anchor the boulder net there at the top. So anchor trench has been made, that is 1 meter deep and 0.5 meter wide, which can be filled further with the soil. Then we have geomembranes, which are thick impervious plastic sheet. These are the impervious plastic sheets, thickness varying from 0.5 mm to 3 mm approximately. So these mainly we use to contain liquid and gases, especially in landfill application or as a moisture barrier. We are using geomembranes there. The first figure, there is a rough surface texture geomembrane is there and smooth double sided geomembrane you can see. So basically we use these geomembranes as landfill lining, as a canal lining, as a tunnel lining there. So geomembrane in landfill, so this is the side slope of the landfill. So when there is a complete fill of the solid waste or waste in the landfill, so when there is a water come in contact with the waste solids, so there will be production of the leachate. So leachate should not go out of this landfill. So to avoid that, we are providing these lining system there. Okay, so below also we are providing the lining system. This is under construction stage. As a canal lining, you can observe here. So geomembrane has been placed before the placing of the concrete lining there. So anchor trench has been made so that the moisture variation won't be there, so that the soil not undergo the moisture variation. Here also tunnel lining as a moisture protection, we are providing geomembrane there. Next we have PVDs, that means prefabricated vertical drains to accelerate the pre-consolidation of soft clay soils. So whenever there is a soft soil is there, also when it is saturated, it is very difficult to compact the soil there. So to increase the consolidation process, we are decreasing the drainage path there. So we know that TV is equal to CVT divided by D square, where TV time factor, which is a function of degree of consolidation. So T, the time required for consolidation, will be given by TV into D square divided by CV. So T is directly proportional to the square of the drainage path. If it decreases the drainage path, so the time required will decreases 2 times. That is the meaning there. So by using this type of highly permeable drainage medium, so you can decrease the flow path there. So you can observe here there is a lateral movement directly. So once it reaches the highly permeable drainage medium, so that the water suddenly moves and you can remove the water very easily. So the time required for that will be very less, so that the rate of consolidation going to increase randomly. So PVDs, if you observe here, this is the figure showing the pre-consolidated PVDs there. So geotextile filter, outside we have geotextile filter, and inside we have highly permeable material that is corrugated plastic core for drainage. So this is the installation of PVDs at construction site. Next we have GCL, which is nothing but geosynthetic clay liners, which consists of, at the center there is a core having bentonite clay which is sandwiched between two thick non-woven geotextiles. So this is, it show in the figure, geotextiles at the outside, and at the center we have dry bentonite powder there. So applied below and above geomembrane layers in the landfill. So whenever there is a damage to the liner system, okay, so the above and below we are providing these GCLs. So whenever there is a damage to the liner system, so this acts as a self repair mechanism. So bentonite expands when the fluid leaks through punctured geomembrane and closes the gap there. So whenever there is a puncture to the liner system, so the leachate may come in contact with the bentonite material. So bentonite is a highly expansive clay, so which expands immediately and that closes the gap there. So we call it as self repair mechanism. Okay. So then we have GEOCELL, which is a 3D confinement product. So this is a plan view has been shown there. So whenever we fill with the soil or aggregate material inside the GEOCELL, so when you apply the load, so there will be the 3D confinement which increases the load carrying capacity, also which increases the load spreading capacity. This is a isometric view, and this is the photograph of an expanded GEOCELL. So advantage of this is easy to transport. Any fill material can be used. We can use any fill material like aggregate or soil or small boulders. Then all around confinement, so it provide the 3D confinement. Then it is a semi-rigid layer, very stiff support, spreads load over the area, and also it is a very good support even under cyclic load. Application, especially this is used as a erosion control, especially for the slope stabilization. We are using this type of structures. Steep slopes or retaining wall construction, also sub-base support. As a sub-base support, these are excellent sub-base supports. Okay, so road bases, railway tracks, also container yards where there is heavy loads are coming. So this is a simple explanation. In figure 1 we have preparation of the ground, then we have stapling to join the different geocells, so that so we can spread in a larger area, stretching up the geogrid layer. Then we are filling stone aggregate filled in geocell pockets, then compaction by a 10-ton roller. This is the unpaved road construction in a factory. So geocells are used to construct a steep slope. You can observe that a steep slope has been stabilized by using geocells there. So the roots are coming through the geocell pockets, so that it will stabilize more. You can see very beautifully the very steep slope has been stabilized, which is very stabilized and very strong in nature. Then we have geocomposites, as I explained previously, which is a combination of two different types of geosynthetics to take advantage of each other. So this is a geogrid with the, at the center we can see there is a geotextile material, so which acts as a reinforcement material as well as filter or suppression layer. So this is a combination of two different geosynthetic materials. So there are different varieties of geosynthetic materials are there. These are different geo others, they like geodrains, which are for the drainage purpose, lightweight fills to fill the low lying areas, geopipes, we have geotextile bags and soil encapsulations, gabion structures, geosynthetic encased stone columns, many others left to the imagination of engineer. Many other geosynthetic materials, combination of one and other we can use. So others, some gabions or stone columns we'll discuss in the next lecture in detail. Thank you.